the beauty of human genome study began with a very big leap in the analytical method. This is called the DNA chip, and it allowed to determine the SNP, maybe 1 million SNPs in one person with about $100. Okay, so for this type of analysis, this is called a Manhattan plot because it looks like the skyscrapers from the Hudson River. This is chromosome 1, 2, 3, 4, until chromosome 22 and X chromosome. And these are 1 million plots over here. And the y-axis this way is the probability that that specific region is a marker for diabetes. So in this study, they use like 1,000 diabetic patients versus 1,000 controls and do some kind of statistical analysis, and they just place the dot. And like that, if it is higher, it means that this region is more susceptible, is likely a diabetic locus. And by doing so, this type analysis was very GWAS, genome-wide association study, was very, very powerful to identify genetic locus for multifactorial diseases, including diabetes, metabolic syndrome, and things like that. So at this moment, 2017, or maybe 16, there are at least 80 SNPs, 80 genes, that account for type 2 diabetes susceptibility. So it's not like monogenic diseases. Even if you check genes, you cannot tell that he or she will develop diabetes. There are 80 of them. And one more thing is that each SNP, the effect is very small. One SNP accounts for like 5 to 20% increase of disease risk. This is very small. Typically, smoking is a risk factor for lung cancer. And the lung cancer will be, let's say, if we think that it increases 3 times, this will be 300%. So you can now see how small one SNP increases the disease risk. You may think that this is something very unlikely or skeptical, but this difference is very robust. There is a 5 to 20% for one SNP. And these have combinatorial effects, and even collecting all of these, at this moment, part of genetic factors can be explained, which means that there is a missing heritability, but I will not talk to this and go forward with what we know now. These are again, the genes by itself does not cause diabetes. In this case, there is a gene and environmental interaction which leads to the metabolic syndrome phenotypes. And these are the studies that we have published. We have published a little bit of them. They have contributed to this field a little bit, but these are the ones. NOS3, SNPs, and daily physical activity regulates blood pressure. ADH polymorphism, SNP, and alcohol intakes blood pressure. And ACE, angiotensin converting enzyme, indel, insertion, deletion, polymorphism, and salt intake regulates blood pressure. IL-6 receptor, this is a inflammatory cytokine receptor, SNP, and energy intake affects obesity.
CFAM, caring for well-being.